What's up, everybody? Welcome to Kinetics, where learning is made easy. Today, we're going to do a general overview of the reticulospinal tract. So, let's go. Y'all, let's dive into this spinal tract. So, before we get into the reticulospinal tract, I'm going to do a quick overview of the nervous system. Within the body, you have peripheral nerves that send and receive signals to and from the central nervous system. The central nervous system is comprised of the brain and the spinal cord. And we're going to break it down a little further. As you can see here, we have cross sections of the spinal cord, medulla, pons, midbrain, and cerebrum. The reticulospinal tract is a part of the indirect motor pathways, which also include the cerebrospinal and vestibulospinal tract. These tracts send nerve impulses from the brainstem to cause automatic movements and help coordinate body movements. The reticulospinal tract receives signals from the reticular formation. The reticular formation receives input from a lot of sources, including the ear, eyes, and cerebellum. The reticulospinal tract receives these signals and sends it down the medial and lateral reticulospinal tract, which sends these signals to skeletal muscles of the trunk and proximal limb muscles. The medial reticulospinal tract excites the skeletal muscles of the trunk and extensor muscles of the proximal limbs, while the lateral reticulospinal tract inhibits skeletal muscles of the trunk and extensor muscles of the proximal limbs. Both tracts work together to maintain posture and regulate muscle tone during movements. The reticular formation is located throughout the brainstem. However, we will focus on its locations in the pons and medulla as they are the source of the activation for the medial and lateral reticulospinal tract. Here in the pons is the depiction of the reticular spinal tract. This is also known as the pontine reticular formation. Here is a cross-section of the medulla, and within the medulla lies the reticular formation. This is known as the medullary reticular formation. The signal from the reticular formation in the pons sends its signal down the spinal cord to the lateral reticulospinal tract, and the signal from the reticular formation in the medulla sends its signal down the spinal cord to the medial reticulospinal tract. So here you can see the signal from the pontine reticular formation in the pons, as well as the medullar reticular formation in the medulla, sending its signal down the brainstem until it reaches the spinal cord. Within the spinal cord, the lateral reticulospinal tract is located on the lateral aspect of the spinal cord, while the medial reticulospinal tract is located on the anterior aspect of the spinal cord here. Here, the signal from the medial reticulospinal tract is going to travel through the medial reticulospinal tract in the anterior aspect of the spinal cord and synapse with the motor neuron, while the lateral reticulospinal tract is going to travel through the lateral reticulospinal tract on the lateral aspect of the spinal cord and synapse with the motor neuron within the ventral horn of the spinal cord here. The signal continues to activate extensor muscles of the proximal limbs and trunks for the medial reticulospinal tract and to inhibit skeletal muscles of the trunk and extensor muscles of the proximal limbs for the lateral reticulospinal tract. Here I depicted a man performing a bicep curl. As you can see, the signal gets sent to the trunk extensors from the medial reticulospinal tract to keep an upright position during the standing bicep curl. The signal from the lateral reticulospinal tract is going to the tricep muscles, which work to extend your elbow and shoulder. This signal is inhibiting the triceps, so the man can perform the bicep curl without resistance from the extensors. Here you see the signal from the medial reticulospinal tract activating the extensor muscles to maintain an upright position, while the signal from the lateral reticulospinal tract is inhibiting the extensor muscle, the tricep, so that this man is able to complete a bicep curl. Alright guys, let's recap the steps for the reticulospinal tract. Number 1. Signal from the reticular formation in the pons is sent down the lateral reticulospinal tract on the lateral aspect of the spinal cord. And the signal from the reticular formation in the medulla is sent down the medial reticulospinal tract on the anterior aspect of the spinal cord here. Number 2. Here, the signal synapses with a motor neuron in the ventral horn of the spinal cord and exits the spinal cord to excite extensor muscles of the proximal limb and trunk. Number 3. Information from the medial reticular spinal tract excite extensor muscles of the proximal limb and trunk, while the signal for the lateral reticular spinal tract inhibits extensor muscles of the proximal limbs and trunk. Alright everyone, thank you so much for watching. Make sure you subscribe, like, share, and leave comments. Tune into my next video where we will take a look at the vestibulospinal tract. Thanks for watching.